For decades, we imagined fast robots as a distant fantasy, something reserved for sci-fi movies, anime battles, or glossy concept art that never quite made it out of the lab. Robots were supposed to be slow, careful, clumsy even. Machines that hesitated before each step, calculating, correcting, wobbling just enough to remind us they weren't alive. That era is officially over. Today, a new generation of machines is emerging from China, and they don't just move fast, they explode into motion. They sprint, leap, pivot, and recover with a confidence that feels disturbingly biological. Some of them run faster than trained athletes. Others maintain high speeds across deserts, rubble, and mountains. A few don't even need legs to outpace humans. They do it with arms moving faster than your eyes can track. And here's the unsettling part. While much of the world is still struggling to build robots that can walk reliably without falling over, China is already building machines that run like predators. Chinese robotics companies aren't just catching up. They're rewriting what speed, agility, and machine movement even mean. Today, we're counting down the 8 fastest robots ever built in China, culminating in a machine so fast it completely breaks the rules of traditional robotics. By the end of this list, the question won't be how fast can robots get? It'll be how far ahead are we already? Number 8. Unitree G1. At first glance, the Unitree G1 doesn't look intimidating. Standing just over 4 feet tall, with a compact frame and a relatively friendly design, it almost feels like a teaching assistant. Something you'd expect to see in a university lab or a robotics classroom. And that's exactly the point. Priced at roughly $16,000, the G1 is one of the most affordable humanoid robots ever built that can actually run, not shuffle, not speedwalk. Run. Once it starts moving, the illusion of harmlessness disappears. With up to 43 degrees of freedom, the G1's motion feels smooth and deliberate. Its legs cycle cleanly. Its torso dynamically counterbalances every stride, and its arms stabilize mid-run the way a trained athlete naturally would. There's no frantic overcorrection, no jerky panic movements, just calm, controlled speed. What makes the G1 truly important isn't raw velocity, it's accessibility. For the first time, high-speed humanoid locomotion isn't locked behind million-dollar research budgets. Students, startups, and independent labs can now experiment with real running humanoids. That means more data, faster iteration, and an explosion of innovation downstream. The G1 isn't meant to be the fastest robot on Earth. It's meant to be the robot that teaches the next one how to be faster. And in that sense, it may be one of the most dangerous machines on this list. Not because of what it can do today, but because of what it enables tomorrow. Number 7. Unitree H1. If the G1 is a gateway, the Unitree H1 is a statement. In early 2024, a short video rippled through the global robotics community. It showed a humanoid robot actually sprinting, at 3.3 meters per second. No cables, no slow-motion trickery, just raw forward acceleration. For the first time, a bipedal robot didn't look like it was trying to run. It looked like it knew how. Standing nearly 6 feet tall and weighing under 110 pounds, the H1 has the proportions of a competitive athlete. Its legs fire with piston-like force. Its control system adjusts posture in milliseconds, shifting weight and correcting balance faster than most humans consciously can. Stairs. It climbs them without hesitation. Obstacles. It dodges smoothly. Flat ground. It becomes something else entirely. Internally, Unitree has reportedly pushed prototype versions of the H1 to speeds approaching 11 miles per hour, edging into territory that would challenge amateur human runners. But the H1's significance goes beyond speed. This robot marked a turning point. China wasn't just following Boston Dynamics anymore. It wasn't imitating Western research labs. It was leading and doing so openly, confidently, and at scale. The H1 sent a clear message. Humanoid running is no longer experimental. It's operational. And once that barrier fell, the next machines didn't just run faster, they ran farther. Number 6. Robot Era Star 1. Speed in a lab is impressive. Speed in the real world is something else entirely. The Robot Era Star 1 didn't earn its reputation on smooth floors or controlled environments. It earned it in the Gobi Desert. In 2024, this bipedal humanoid ran continuously for 34 minutes across the Hexi corridor, one of the harshest testing environments imaginable. Sand, gravel, grassland, rocky inclines, uneven terrain that would exhaust even trained human runners. The Star One didn't stop. It adjusted stride length, foot placement and balance in real time, adapting to each surface as it went. No pre-mapped path, no gentle conditions, just raw terrain and persistent forward motion. Then came the experiment that went viral. 2 identical Star One robots were sent down the same course. One ran barefoot. The other wore shoes. The one with shoes won. For the first time in history, researchers proved that footwear improves robotic running performance, a small detail that hints at how close these machines are getting to biological optimization. The Star One didn't just demonstrate speed. It demonstrated endurance, adaptability, and environmental resilience. 3 qualities that push humanoid robots out of labs and into the real world. And once you master endurance, the next step is dominance. Number 5. Robot Era L7. If the Star One is a survivor, the Robot Era L7 is a performer. Standing 175 centimeters tall with an astonishing 55 degrees of freedom, the L7 moves with a fluidity that feels almost choreographed. When it accelerates, there's no hesitation, just a clean transition from stillness to motion. The L7 reaches speeds of 4.0 meters per second, powered by joints capable of delivering 400 Newton-meters of torque. That's enough force not just for sprinting, but for spinning, twisting, jumping, and even executing complex dance-like routines. But this isn't a fragile showpiece. The L7 can lift 20 kilograms while maintaining balance. It uses full 360-degree multi-sensor fusion, constantly mapping its environment and adjusting movement in every direction at once. At around $120,000, it's one of the most advanced full-sized humanoids available anywhere on Earth. This robot doesn't just move like a human, it moves like a trained one. And while elegance is impressive, the next machine on this list abandons elegance entirely in favor of something far more unsettling: raw industrial speed. Number 4. Unitree B2. The Unitree B2 wasn't built to race, it was built to work, and yet, it can sprint at 6 meters per second while carrying loads up to 250 kilograms. That combination alone makes it a category breaker. With joint torque reaching 360 Newton meters, the B2 accelerates under heavy weight, climbs stairs without losing stability, and navigates unpredictable terrain with confidence. Mines, disaster zones, warehouses, construction sites, this is where the B2 thrives. Most industrial robots sacrifice speed for stability. The B2 refuses to make that trade. Watching it run is jarring because your brain expects something slow and methodical. Instead, you see a machine charge forward like a compact vehicle, balanced, powerful, and relentless. It's not trying to look human. It's trying to be effective. And it is. But even the B2 still plays by the rules of legs and ground contact. The next robot breaks those rules entirely. Number 3. Astrobot S1. The Astrobot S1 doesn't run, it doesn't walk, and yet it's one of the fastest machines on this list. The S1's arms move at 10 meters per second, faster than the human nervous system can reliably react. That speed allows it to perform tasks that feel almost supernatural, pulling tablecloths from under stacked glassware, slicing vegetables mid-air, drawing intricate characters with flawless timing. Each arm handles payloads of up to 10 kilograms, yet maintains feather-light precision. This isn't brute force, it's reaction speed. In factories, kitchens, labs, and precision assembly lines, the S1 operates at a tempo humans simply can't match. No fatigue, no hesitation, no missed beats. It proves something important. Speed isn't always about distance. Sometimes it's about time. And when it comes to pure sprinting power, only 2 robots remain. Number 2. Black Panther 2.0. Watching Black Panther 2.0 run is deeply unsettling. Weighing just 38 kilograms, this compact quadruped can cover 100 meters in under 10 seconds, a time competitive with Olympic sprinters. Its movements don't look mechanical, they look alive. That realism comes from biology-inspired engineering. Carbon fiber legs modeled after jerboas provide explosive rebound. Spring-loaded joints mimic animal tendons. Specialized running shoes inspired by cheetah paws improve grip by over 200%. AI gait control synchronizes each leg using principles derived from predator locomotion, coordinating movement the way nature refined over millions of years. Black Panther 2.0 doesn't imitate animals, it competes with them. And yet, even this mechanical predator isn't the fastest thing China has built. Number 1. Unitree B2W. The Unitree B2W doesn't just break records, it breaks expectations. At first, it moves like a traditional legged robot, stepping carefully, articulating each limb with precision. Then, without warning, the legs reconfigure. Wheels engage, and the machine launches forward. In seconds, it reaches speeds approaching 30 miles per hour. This hybrid robot seamlessly transitions between walking, running, and rolling, carrying loads up to 40 kilograms while maintaining stability at velocities most robots can't survive. Every movement is controlled by high-speed actuators and predictive algorithms designed for one goal: maximum mobility. The B2W doesn't choose between legs and wheels. It uses both, instantly, intelligently, and ruthlessly. This isn't just the fastest robot in China. It's the fastest mobile robot on the planet. These machines aren't prototypes anymore. They're products, platforms, foundations. China isn't just building fast robots, it's building an ecosystem where speed, agility, and autonomy are expected, not experimental. The question now isn't whether robots will outrun humans, it's where, when, and why. So which one shook you the most? The desert-running humanoid, the mechanical predator, or the hybrid machine that moves faster than anything else on legs or wheels? Drop your thoughts in the comments, because one thing is clear: the future isn't walking toward us anymore. It's sprinting.